So today we're going to be solving this geometry problem using some trigonometry rules we learned throughout this channel. So this problem is from Langley's Adventitious angles problem, and which is written by a mathematician called Langley. And basically, this problem is really famous for being one of the hardest geometry problems. And there are multiple solutions for it, but in this video, I'm going to be showing you a solution that uses many of the trigonometry rules we learned in trigonometry rules. So and the reason this problem is one of my favorite geometry problems is that it uses so many of the trigonometry rules to solve it, and it works really elegantly. So, yeah, I hope you guys find this solution really elegant and interesting too. So let's read the problem first. So triangle ABC is an isosceles triangle with AB is equal to AC. So AB is equal to AC. And angle A is equal to 20 degrees. Is equal to 20 degrees. And D and E are points on AC and AB respectively, such that angle DBC is equal to 60 degrees. Angle DBC is equal to 60 degrees. And angle ECB is equal to 50 degrees. ECB is 50 degrees. Coolio. Then find the measure of the angle BDE. Angle BDE. Let's just call it theta so that we can just remind ourselves that this is the angle that we're looking for. So before we start, let's do some basic angle tracing to find some angles that will be useful in knowing to solve our problem. So firstly, since AB is equal to AC, then angle ABC will be equal to angle ACB. So because ABC is an isosceles triangle, yeah. So angle ABC is equal to angle ACB, which means that angle ABC or angle ACB will be equal to 180 degrees minus angle A, which is 20 degrees. So 180 degrees minus 20 degrees divided by 2, which is 160 divided by 2, which is 80 degrees. So angle ABC or angle ACB will both be 80 degrees. So this entire angle will be 80 degrees, and this entire angle will be 80 degrees. So since this entire angle is 80 degrees, and this is 60 degrees, then this angle is going to be 80 degrees minus 60 degrees equals 20 degrees. And similarly, since this entire angle is 80 degrees, and this angle is 50 degrees, this angle is going to be 30 degrees. Coolio. So now let's look at triangle BCE. So the measure of angle BEC will be equal to 180 degrees minus 80 degrees minus 50 degrees, which is 50 degrees. So here we see that angle BEC is equal to the measure of angle BCE. So angle BEC is equal to angle BCE, which means that BE is equal to BC. So BEC, the triangle BEC, is isosceles with sides BE being equal to side BC. So that's important to note. So let's mark that down. Okay, and now let's focus on triangle BCD. So again, the angle BDC will be equal to 180 degrees minus 60 degrees minus 80 degrees, which is 80 degrees, 40 degrees. There you go. So yeah, we've got all the angles that we've done all the basic angle chasing. So now all we have to do now is just get into the real trigonometry. So again, let's focus on triangle BCD. And we're gonna use the sine rule to find the length of BD. So firstly, according to the using the sine rule in triangle BCD, the length of BD to the sine of 80 degrees. Oops, my handwriting is really messy. Sine of 80 degrees is equal to is equal to the length of BC to the sine of 40 degrees. So the ratio of BC to the sine of 40 degrees. There you go. Oh yeah, one more thing before this. So before this, let's say that the length BE is equal to 1. Because this problem didn't really state like the lengths, but then let's just designate a value for like the length of something to make calculations easier. So let's say BE is equal to 1, and since BC is equal to BE, then BC is also going to be 1. So here, since BC is equal to 1, so this can be rewritten as, just leave that. Will be equal to, BC is equal to 1, so that'll be 1 and 1 over sine of 40 degrees. There you go. So the ratio of BD to sine of 80 degrees is equal to 1, the ratio of 1 to sine of 40 degrees, which means that BD is equal to the sine of 80 degrees over the sine of 40 degrees. There you go. And this looks pretty simple, but then we can make this expression a bit simpler using one of our formulas. So we kind of see a relationship here. So 80 degrees is double of 40 degrees. So what formula can we use for this? Well, the double angle formula, because 80 degrees is double of 40 degrees. So it kind of gives us a clue that we can use. Maybe we can use the double angle formula to rewrite sine of 80 degrees as another kind of expression. So the double angle formula for sine tells us that the sine of 2 alpha is equal to 2 times sine of alpha times cosine of alpha. So then sine of 80 degrees can be written as sine of double of 40 degrees. So we can substitute 40 degrees into alpha to get that sine of 80 degrees is equal to 2 times sine of 40 degrees times cosine of 40 degrees. There you go. So we can rewrite this as, so sine of 80 degrees can be written as this, 40 degrees times cosine of 40 degrees over sine of 40 degrees. And there you go. This cancels out. That's pretty neat. So this cancels out to get us to 2 times cosine of 40 degrees. So BD is equal to 2 times cosine of 40 degrees. There you go. So we're going to just write that here. So BD is equal to 2 times cosine of 40 degrees. There you go. So we're just going to remember that. Okay. Oh wait, let me get my eraser to erase this. Okay, so we found the length of BD, which is this. And now let's take the time to observe this diagram to kind of get a sense of how to get theta. So, by the sine rule for triangle BDE, we're going to focus on triangle BDE because theta is one of the interior angles of triangle BDE. So, by the sine rule in triangle BDE, we see that the ratio of BE, of the length of BE to the length of BE to the sine of theta will be equal to, let's rewrite that, it's too messy. Sine of theta is equal to the ratio of DE to the sine of 20 degrees. DE sine of 20 degrees. So this value is known, so BE is equal to 1, so we already know this value. And we already know this value. And we don't know this value. But then if we get this value, if we get to know this value, then we can automatically find the value of theta, because then all three values of these will be known. So if we find the value of if we find the length of DE, we can automatically find the value of theta. So we're going to aim to find the length of DE. And yeah, so now we're gonna focus on trying to find the length of DE. So let's just remember that. But we're gonna erase it to get more space because the solution's gonna be really, really long. So firstly, we're gonna use the cosine rule in triangle BDE. So by the cosine rule in BDE, DE squared will be equal to BE squared plus BD squared minus 2 times BE times BD times cosine, oops, let's just put that multiplication sign there, times cosine of, times the cosine of 20 degrees, because, yeah, the cosine of 20 degrees. Then, if we plug in our known values, we know that BE is equal to 1, so 1 squared is just 1. BD is equal to 2 times cosine of 40 degrees, and that squared will be equal to 4 times cosine squared of 40 degrees minus 2 times BE, so BE is equal to 1, so negative 2 times 1 will just be negative 2, so negative 2, so minus 2 times BD, which is 2 times cosine of 40 degrees, there you go, times cosine of 20 degrees. There you go. And let's simplify this to get that 1 plus 4 cosine of 40 degrees minus 4 times cosine of 40 degrees cosine of 20 degrees. There you go. Okay, so, and then here we can factor out 4 times cosine of 40 degrees. So 1 plus 4 times cosine of 40 degrees cosine of 40 degrees minus cosine of 20 degrees. There you go. And now this we found what DE is, but then this is kind of really complicated, and we don't want to square root this to find DE. It's going to be too complicated. So we want to simplify this using our trigonometric identities that we learned throughout this channel. So maybe we can rewrite this expression as something simpler. Well, this kind of looks similar though. And if you think about it, we saw this form in the sum to product formulas for sum to product trigonometric identities. So we can use that formula to rewrite this as something simpler. So yeah, let's try it out. So by the sum to product rule, we know that, okay, it's gonna take quite a while for me to recap this too. Cosine of, actually I'm gonna put that in pink so that we can see that it's kind of, a rule that we have to know. So cosine of, if we get a form like cosine of A minus cosine of B, then we can rewrite that as negative 2 times sine of A plus B over 2 times the sine of A minus B over 2. There we go. So here we're going to substitute. So here we're going to rewrite this in the form of this. So using this formula, cosine of 40 degrees minus cosine of 20 degrees will be equal to, so here A is going to be equal to 40 degrees and B is equal to 20 degrees. So just substitute those in to get negative 2 times sine of 40 degrees plus 20 degrees divided by 40 degrees plus 20 degrees divided by 2, which is 60 divided by 2, which is 30 degrees, times the sine of 40 degrees minus 20 degrees divided by 2, which is 20 degrees divided by 2, which is equal to 10 degrees. And we can rewrite this as, before that. So we know what sine of 30 degrees is, which is a half. So negative 2 times a half will be negative 1. Negative 1 times sine of 10 degrees will be negative sine of 10 degrees. There you go. So we found what cosine of 40 degrees minus cosine of 20 degrees is equal to, which is negative sine of 10 degrees. And this looks much simpler than this. So let's substitute that in here. So let's just erase this to get more space. So as we got before, this will be equal to 1 plus 4 times cosine of 40 degrees times, and this will be equal to negative sine of 10 degrees. And this can be simplified to, so multiply the negative, and just factor out the negative out there to get, plus, so minus 4 times cosine of 40 degrees times sine of 10 degrees. Ugh, running out of space. So again, this expression is pretty simple, but we can make it simpler. So can we rewrite this expression as something simpler? Well, this form of expression is actually kind of familiar from the product to sum formulas for the trigonometric identities. So, So by the product to sum rule in the trigonometric identities, let's put that in pink for the formulas. We know that cosine of A times sine of B is equal to half times the sine of A plus B minus the sine of A minus B. So here, as we see here, we see that this is in the form of this, like the cosine of something times the sine of something else. So we can rewrite this in the form of this. So let's write that. Cosine of 40 degrees times times sine of 10 degrees can be written as, so here A is equal to 40 degrees and B is equal to 10 degrees. So substitute those in to get half times sine of 40 degrees was 10 degrees, which is 50 degrees, minus sine of 40 degrees minus 10 degrees, which is 30 degrees. There you go. And here, sine of 30 degrees is equal to a half. So we know that this is a half. So this expression simplifies to half times sine of 50 degrees minus a half times a half, which is a quarter. So we get that. So cosine of 40 degrees times sine of 10 degrees is equal to half of sine of 50 degrees minus 1/4. So we have two trigonometric expressions here, but we go one. So we simplify. So we have successfully simplified this. So let's remember that way. So this is equal to that. So we're going to erase this to get more space. Okay. And so this can be rewritten as 1 minus 4 times. So what did we get before? We got a half of sine of 50 degrees minus a quarter. Yeah. And then if we simplify this, we get, let's do some quick math here. If we expand the brackets, we get 2 minus 2 times sine of 50 degrees. And this is actually equal to, and we can actually factor out the 2 to get 2 times 1 minus, actually this is kind of cramped here, so I'm going to just use the next line. So this is equal to, factor out the 2, 1 minus sine of 50 degrees. There you go. But then we can also rewrite sine of, so we know that the sine of an angle is equal to the cosine of an angle that is the complementary angle of that angle. So sine of 50 degrees is going to be equal to the cosine of 90 minus 50 degrees, which is 40 degrees. So sine of 50 degrees is equal to cosine of 40 degrees. So we can rewrite this as 2 times 1 minus cosine of 40 degrees. And now we can simplify this further. So cosine of 40 degrees can be rewritten as another expression using the double angle formula. So what was the double angle formula for cosine again? Well, it was cosine of 2 alpha is equal to 2 times cosine squared alpha minus 1. There you go. And we're going to use this to express cosine 40 degrees in a new way. So that can be rewritten as cosine of 2 times 20 degrees, which can be rewritten as, so substitute 20 degrees into alpha to get 2 times cosine of 20 degrees squared minus 1. Yeah, so this is equal to this. So we're going to substitute this into here. Okay, so let's erase this again to get more space. Okay, so this will be equal to, let's get a new line, 2 times 1 minus 2 times cosine squared of 20 degrees minus 1. Yeah. And this simplifies to, I'm going to just do some quick math. This will simplify to 4 times 1 minus cosine of squared. Actually, I'm just going to show you all the working out to make it more clear. So here we get 2 times 2 minus 2 times cosine squared of 20 degrees. And this can be simplified to 4 times, so factor out the 2 again to get this, cosine squared of 20 degrees. There you go. And look here, this looks pretty familiar. Which is, so sine squared of an angle plus cosine squared of an angle is always equal to 1. So 1 minus cosine squared of 20 degrees is going to be equal to sine squared of 20 degrees. So this can be rewritten as 4 times sine squared of 20 degrees. Look here, we got a really simple expression. And you know what? This is equal to dE squared, and this can be easily, easily square rooted, because if you square root this, because 4 is 2 squared and sine squared of 20 degrees is sine 20 degrees squared. So dE squared is equal to that. So dE is equal to that square rooted, which is 2 times sine of 20 degrees. 2 times sine of 20 degrees. And we got our answer. Yes, we got the length of dE finally. And what does this mean? So as we said before, if we find this, we can automatically find the value for theta. So there you go. So we can write this here to remind ourselves. 2 times sine of 20 degrees is equal to dE. Wow, that was a lot of work. But we're going to have to erase this for more space. Okay, so now we're going to just use the sine rule that we used before to find theta. So BE, the ratio, I'm going to actually write in black. The ratio of BE to the sine of theta is equal to the ratio of dE to the sine of 20 degrees, as we discussed before. Okay, and we know what BE is. It's 1, and sine of theta is just sine of theta. And dE is equal to 2 times sine of 20 degrees, and this is sine of 20 degrees. And you know what? Something that's much better is that this cancels out. So we get that sine of theta is equal to a half. And here we can clearly see that theta has to be an acute angle. So it has to be between 0 degrees and 90 degrees. So the only angle theta between 0 degrees and 90 degrees that satisfies that its sine value is equal to a half is theta equals 30 degrees. And there we have our answer. So yeah, that's the answer, 30 degrees. Whoa, that was a really long problem. So I hope so basically the reason I showed you guys the solution and put this as a video is because this problem uses so many of the trigonometry rules, and it shows all the ways that you can use trigonometry to solve a geometry problem, like it says here. So yeah, I hope you guys now understand that, now kind of get the clear idea of how to use trigonometry and it's like various rules and formula to solve geometry problems like this. So yeah, I hope you guys learned a lot from this video, and yeah, I hope you guys enjoyed the solution and found it pretty interesting. Yeah, see you later.